All right, let's talk about this Le Chatelier's principle of practice. So it says, for the reactions that have reached dynamic equilibrium, the system changes in a way that relieves added stress. These stresses can come in the form of concentration, temperature, or pressure. And for simplicity's sake, we're going to consider the left side of the chemical equation the reactants and the right side the products. All right. So number one, what would happen to the position of the equilibrium when the following changes in concentration are made to the system below? We have our equation here, and we can see that they're all gases. Sulfur dioxide is added to the system. So if we add sulfur dioxide, increase that, it will shift to the left to compensate for that added stress. Sulfur trioxide is removed from the system. So if we lower this, it will also shift to the left. And then C, oxygen is added to the system. If we add oxygen, it's similar to adding sulfur dioxide, and it will shift left. Okay, moving on. Predict the effect of increasing the pressure of the container for each equilibrium. Okay, increasing the pressure will favor fewer moles of gas. Okay, so keep that in mind here. We're looking for the side that has fewer moles of gas. So I would first go ahead and check and make sure that each of these are gases, which they are. 2 plus 1 is 3. Compare that to 2 plus 2, which is 4. So it will shift to the side that has fewer moles of gas, which is left. Part B here, we have a solid here, silicon dioxide. So we're going to ignore that one. This is 4 moles of gas versus 1 plus 2, which is 3, so it's 4 to 3. So that will shift right, favoring the side that has fewer. And then C, we have carbon monoxide, hydrogen, carbon is a solid. We're going to ignore that one too. And water vapor. So this is a 2 to 1 ratio of moles of gas. So it's going to favor the right side, and it will shift right. Okay. Let's move on to number 3 here. Number 3 says, predict the effect of decreasing temperature on the position of the following equilibria. Hint, determine if the reaction is endothermic or exothermic first. The way you determine that is pretty simple. Simply consider heat or added energy or energy released as a reactant or product. Here we can see that in kilojoules, heat is being released because it's on the product side. So that would be exothermic. Likewise here, and then endothermic here because it's on the left side. So let's go through these. If you're decreasing temperature, we would decrease this side, so it would shift right to compensate. Number 2, if we do the same thing, it will shift right. And if we decrease temperature on the left side, it will shift left to relieve the stress. And number 4, state the direction in which each of the following equilibrium systems would be shifted upon the application of the following stresses. So this is a mixed bag. Let's just go over each one. So a decrease in temperature. This one has energy on the right side with the products, so it's exothermic. If you decrease that, it will shift right. An increase in temperature for this one, with energy being on the left side as a reactant, an increase in that will shift it to the right as well. Okay, this next one, an increase in pressure. We have to look at the moles of gas here, 1 versus 2. If you increase the pressure, it's going to favor the side with fewer moles of gas. That would be to the left. And then a decrease in pressure will favor more moles of gas. We have 2 versus 3, so that will be to the right. Okay, an addition of iron. Iron is right here. It is a reactant. So if you add this, it will shift to the right, favoring the products. And lastly, a decrease in pressure. We have to count up the moles of gas. 1 plus 1 is 2. 1 plus 1 is 2. So it's a 2 to 2 ratio, which means that it doesn't prefer shifting either direction. The same number of moles of gas on each side results in no change. All right, hopefully you found that useful. I'll see you next time.